Hello Honors Pre-Calculus students, this is Mr. Cazzato and this lesson is about inverse functions. So we may have started this in class but we may not have finished it, so we're going to go through the whole lesson from start to finish. You can fast forward as needed. So if you look at the problem on the screen, I'm going to do problem A and C. I'm going to find f of 3 and f of 4, and I want you to find part B and D. So go ahead and pause the screen and go ahead and find B and D, please. And I'm going to do part A and C. Okay, so when I plug in -3, I get 28. And when I plug in f of 4, I get -63. And then I'm also going to do part E. I want you to do part F. So you've done part B and D. Now go ahead and do part F while I do part E. And I'm also going to explain it as needed. So f of g of x, so good notation. So f of g of x, first I'm going to substitute in g. So cube root of 1 minus x. And then this number that I just highlighted in yellow gets substituted in for x in the function g. So 1 minus the cube root, 1 minus x, that quantity cubed. The cube root and the power of 3 undo each other, so 1 minus parenthesis, 1 minus x. And when you distribute, you get x. So when I compose f of g of x, I get x. So at this point, you should have done part B and D. And you should have realized when you did g of -63, you get 4. G of 28, you get -3. And when you compose g of f of x, you should have came up with x. So the idea that we're trying to teach you here is, if you look at part, let me undo that. If you look at part A, and you look at part D, you look at part C, and part B, you should notice that those are kind of undoing each other, and the concept is these are called inverse functions. The second thing you should notice is in part E and F, when you compose them, you get x both ways. So the idea that we're trying to refresh your mind about from maybe Algebra 2 is the following. If f of g of x is equal to x, and g of f of x is equal to x. Now the technical definition says for all x in the domain. Then f and g are inverse functions. And the way we denoted an inverse function, I'm going to write this in the top corner here. This notation, f inverse of x, represents the inverse function. So if I, just for completeness of our notes, f inverse, since we know they're inverses because we compose them, is the cube root of 1 minus x. That -1 does not mean reciprocal. It's not an exponent. All right, second thing we wanted you to be able to do is find the inverse function. So we wanted to see if you remember how to find the inverse function. And every year people kind of usually give me the steps. I'm going to write them in the middle. 1, you let y be equal to x. Step 2, you switch the x's and y's. And then step 3, you solve for y. And I typically then rename the function. Meaning call it f inverse, or in letter B, if it's g inverse, call it g inverse. All right, so go ahead and do part A. Pause the screen, go ahead and do part A, and then I'll go through it, and then you're going to pause the screen again and do part B. All right, so here's part A. Y is equal to 2x plus 3. I'm going to switch the x's and y's. and then I'm going to solve for y. So I'm going to subtract 3, and then I'm going to divide by 2. And then the last step, what I meant by rename it, is I'm going to call this f inverse. Oops. So f inverse of x is equal to x minus 3 over 2. All right, part B is a rational function, and this has a little bit more algebra steps, and calculus has a lot of algebra. So see if you can follow those blue steps and try part B on your own. When you need to, come back and kind of watch the video. All right, so here's step 1. So you're just calling it y. Step 2, I'm going to switch the x's and y's. Okay, at this point, I'm going to multiply by y minus 1. And now I got to use my algebra skills. The goal is to solve for y, so I'm going to distribute. And this is where sometimes people have some trouble, so I'm going to write this at the top of the screen. If the problem said 3y minus 10 equals 2y plus 17, you would put the 2y on the left-hand side and the 10 on the other side. So I'm going to use that idea that I wrote there. So I'm going to get the y's on one side, and I'm going to move the x to the other side. Okay. When you do that over here, you would get y is equal to 27. You would take the 3 and the 2 and just do the subtraction. But here we can't do that, but we can factor out the y. So we can factor out the y. And then at that point, I could divide by the x minus 2. So y is x plus 1 over x minus 2. And we denote that G inverse. So looking at these steps, step 1, just call G of x y. Step 2, switch the x's and y's. Then step 3a, I multiply by y minus 1. 3b, distribute. 3c, I move the y's to one side and everything else to the other side. 3d, I factored. 3e, I divided. And then step 4, I just renamed. So hopefully that helps you understand the process of finding the inverse function. All right, the next part of the lesson, we have this visual here, kind of what happens. So because the x's and y's are switching, the domain of the function is the range of the inverse. The range of the function is the domain of f inverse. So that's probably the cleanest way to say that. The domain of the function is the range of f inverse. The range of the function is the domain of f inverse. All right. We already did part A, verify that they were functions. So we already figured out earlier, we did f of g of x. We saw that that was x. We did g of f of x. We saw that that was equal to x. So we already did part A. I'm going to go back up here and show that to you. So we did part A at the beginning of class, so I'm not going to repeat that. So we know that those two are inverse functions. Letter B, verify these are inverse functions. So you have to do g of f of x, and you also have to do f of g of x. So I'm going to do the red one, you could do the blue one, and you should be able to verify that they are inverses. So I'm just going to do the red here. So good notation. Let me get my red pen here. So f of g of x. Now Miss Gilbert just called this f inverse, so I'm just going to call that g of x. That probably should have been g of x. I'm going to just change that. Same thing down on this one. This probably should have been g of x. So f of 1/2 x minus 3/2. Ms. Gilbert knew that they were inverse functions because she wrote the problem, but most textbooks are just going to call that g of x. You're trying to verify that they are. And then you're going to take that and plug it in. So I'm going to take this blue piece and plug it in. So 2 times 1/2 x minus 3/2 plus 3. When you distribute, you get 2x minus 3 plus 3, and I distributed wrong. When you distribute properly, you get x minus 3 plus 2. And when you simplify, you get x. So that should have also worked in g of f of x. You should have got x. So then you can make a conclusion. F of x and g of x are inverse functions. Okay, for part C, we want to verify f and g are inverse functions. So we need to do f of g of x. And we also need to do g of f of x. Okay, and for both of those, we need to show that they're equal to x. So I'm going to do the one on the left. So f of g of x is x plus 1 over x minus 2. So this function that I just highlighted in yellow gets placed in for this x. So in the next step, it'll be f of, oops, no more f. It'll be, okay, for part C, we need to verify f and g are inverses. In order to do that, we need to find f of g of x. And so the first step is f of x plus 1 over x minus 2. So this yellow function that I just highlighted goes in place of these yellow x's in the function f. So the next step is going to be 2 times the quantity x plus 1 over x minus 2 plus 1 divided by x plus 1 over x minus 2 minus 1. At this point, there's a couple ways you can do it. You could get a common denominator in the numerator, common denominator in the denominator, and then invert and multiply. Last year, your counterparts in pre-calculus liked to multiply by this number in blue, which is the number 1. So they creatively multiplied by the number 1. I'm going to put brackets around that, and then they distributed. So this seemed to be the most favorable method. There are other ways of doing it. So when you do that, you get 2 times the quantity x plus 1 plus x minus 2 divided by x plus 1 minus the quantity x minus 2. Make sure you put parentheses here that I'm highlighting in green. So then when you distribute, 2x plus 2 plus x minus 2, check my math please, divided by x plus 1 minus x plus, which is equal to 3x over 3. And 3x over 3 is x. So I just showed f of g of x was equal to x. You also need to show g of f of x is equal to x. So I'm going to leave that for you. And if both f of g of x and g of f of x are both equal to x, then we know that they are inverses. All right, the last thing we want to show you is this Desmos. So this is kind of something that we'll put on the website, but I'm going to show it to you too. It's more of a teacher-led activity. So I'm just going to click it here. So can you visualize what the inverse function looks like? And so we've been doing a couple things here. Notice when you compose them, you get x. So that's a clue. And last year during this conversation, because when you compose them, you get x, someone mentioned the line of symmetry. So can you think of the line of symmetry? And here's what the inverse function looks like. And then hopefully now you can see the line of symmetry is the line y equal x. So because when you compose them, you get x both ways, the line of symmetry is y equal x. So earlier we talked about the x's and y's switching. So when I go back to this slide, hopefully you kind of realize the x's and y's are switching. So this point down here, where my mouse is, it looks approximately like 4, -4 approximately. Maybe that's not true. Yeah, it's approximately 4, -4. And then looking over here, this is approximately the same point. Okay, the resolution may not be perfect. All right, so the idea was the line of symmetry is y equal x. So what does the inverse here look like? So I'm going to draw in the line y equal x. And then if you were to reflect that red graph over the line y equal x, you would get the following graph. What do you notice about the blue graph? Hopefully you realize that that blue graph does not pass the vertical line. So I was very careful the way I phrased this. What does the inverse of the function look like? The blue is the inverse, but it is not a function. In contrast, this red graph, I wrote what does the inverse function looks like. And when you find the inverse, you get the blue graph, and that blue graph is an inverse function. So sometimes functions have an inverse, sometimes they have an inverse function. So we wanted to discuss, like, well, how do you know if the inverse is a function or not? So to tell if something's a function, we use the vertical line test. That vertical line test will show us that that blue graph is not a function. So what's the equivalent to finding out if a function has an inverse function? If you think about the x's and y's are switching, then the equivalent to the vertical line test would be a horizontal line test. So here's a summary. If a function passes the horizontal line test, then the inverse function exists. So a function has an inverse function if it passes the horizontal line test. And hopefully that makes sense because the x's and y's are switching. The vertical line test tells you if it's a function. So the horizontal line test that I'm highlighting here tells you if the inverse is a function or not. We give a special name. So if a function passes the horizontal line test, we say it's a one-to-one function. What does that mean when we say a function is one-to-one? It means the inverse is also a function.